Okay, so we have trigonometry, right? There are 6 trig functions that you should be familiar with, right? Our 3 basic ones, sine, cosine, and tangent, right? Those 3 basic ratios. So if we were to have a right triangle, okay, and we had our reference angle, right? There are 3 sides. We have the opposite side to your angle, we have the adjacent side to your angle, and of course we have the hypotenuse of your triangle. Sine is a ratio of the opposite side length to the hypotenuse side length. Cosine is a ratio of the adjacent to the hypotenuse, and the tangent is a comparison of the opposite side to the adjacent side. Right, those are our 3 basic trig functions that you should have learned in geometry. Now the 3 new ones that we've learned recently are the reciprocals. Cosecant is the reciprocal of sine, so that means it's the hypotenuse over the opposite side. That is the 2 sides that it compares. The secant is the reciprocal of the cosine, which means it is the hypotenuse over the adjacent side. That is its ratio. And the cotangent is the reciprocal of the tan, which is a comparison of the adjacent side to the opposite side. Okay, so those are our 6 trig ratios that we need to write for every one of these problems. So there are 6 problems. We're going to write it 6 times. 6 is 36 times. So make sure you have enough space on your worksheet to do all the work and write the answers. Okay, because first we start by plotting our coordinates. So here we have the coordinate -1, 3. Okay, so plot that on your paper. You can use tick marks if you want to, or you can just put it over there to the left somehow. Right, this is 1 unit to the left and 3 units up. And we put our coordinate point -1, 3. Okay? And now since this is right triangle trig, we have to make a right triangle. So we draw a vertical line back down to the x-axis, right? That creates your right angle. And then you draw your hypotenuse, which is from the point back to the origin. And that's how we create our right angle, well, right triangle. And our angle is always formed at the origin. Okay, so we're always going to be using the x-axis as one of our sides, and we never ever use the y-axis as one of the sides of our triangle. Okay, we always draw our triangle floating in the air with the bottom as the ground. Okay, so we're going to put in the sides we know. We know that the x-coordinate, or the x distance, is -1. Right, it's to the left of our origin, so that's -1. And the y distance is 3. So for my given angle, I know what the opposite side length is, and I know what the adjacent side length is. But what side am I missing? I'm missing the hypotenuse. And how am I going to calculate my hypotenuse? By using the Pythagorean theorem. So in this case, I have -1 squared, that's a side length, plus +3 squared equals the length of my hypotenuse squared. Okay, and I put the negative in parentheses because if you use your calculator to figure this out, without parentheses, your calculator is going to tell you it's negative, which is a lie. When you square something, it always becomes positive. So -1 squared is +1, plus 3 squared is 9. 1 plus 9 is 10 equals your hypotenuse squared. So our last step is to square root both sides. So my hypotenuse length is the square root of 10. Okay? So now I know all 3 of my sides. I can write down all 6 of my ratios. So now I simply have to write down my ratios. So the sine is the opposite side, which is 3, over the hypotenuse, which is root 10. Okay, now we don't like, and I say we, math teachers basically, don't like having radicals in the denominator. Okay, it's called an irrational number if we have a radical on the denominator. So we're going to do a little fancy thing called rationalizing in order to simplify this. And the reason why we do it is because anytime you have a multiple choice test, like on your AP test, they're going to have their answers written in rationalized form. So you have to be familiar with how they got their answer. So we do that by multiplying top and bottom by radical 10. Okay, by radical 10. So in the numerator, we get 3 radical 10, right? 3 root 10. And in the denominator, root 10 times root 10 is just the normal number 10, right? So it's the square root of 100, and the square root of 100 is 10. So that is how we're going to represent our answer in rationalized form. So whenever we have a radical in the denominator, that is what we're going to do. But don't worry, there's a math hack that I'm going to show you here in a second. Okay, cosine. Cosine is the adjacent side, which is -1 over root 10. Okay. So here's your math hack. Notice that we had a radical in the denominator, but in our answer, it's gone. And where did the radical go? To the top. So that's what we're going to do. We're going to take the radical, put it on top, and no longer have a radical on the bottom. So we have the negative. -1 times root 10 is just negative root 10. I'm not going to write -1 root 10. And on the bottom, we just have normal 10. Okay, and tangent is opposite over adjacent, so that's 3 over -1, which simplifies to -3. Okay, we always want to simplify and reduce as much as we possibly can. Okay, cosecant. Well, cosecant is the reciprocal of sine, so that's the hypotenuse, which is root 10 over the opposite side. Nothing to simplify there. Secant is hypotenuse, which is root 10 over adjacent side, -1. 10 divided by -1 is negative root 10. And then cotangent is -1 over 3. Nothing to simplify there. Okay, so if we can simplify a problem, we should simplify the problem. So here we have another example. Yes, it does happen to be in the second quadrant again, but it's 3 units to the left, so we have an x value of -3, and then we have a y value of 6. So here is the coordinate, -3, 6, right up there in the second quadrant. We draw our triangle by coming down to the x-axis. That forms your right angle. And then we go from our coordinate back to the origin, and that forms our theta. So that means we have another side of +6, right? Positive in the y, so 6. And now we're going to do Pythagorean theorem to figure out what our hypotenuse is going to be. So our hypotenuse is the square root of 45. Now that's not a perfect number, right? 49 is a perfect square, so 45 is not. But can we reduce this? Okay, and the answer is yes. 45 is 9 times 5, right? So if I take split 45 into the square root of 9 times the square root of 5, that simplifies to 3 times the square root of 5. So let's now write down all 6 of our trig words, and then we'll come back for the ratios. So now let's write our ratios. So sine is opposite, which is 6 over 3 roots of 5. Okay, so looking at this, can we simplify anything? The answer is yes, or I wouldn't have asked. 6 divides 3, yes? What is 6 divided by 3? Is 2. So we have a 2 in the numerator, and we have a 1 in the denominator, right? So we're looking at 2 over root 5, which we're going to rationalize, which will end up as 2 root 5 over 5. Okay, remember the radical goes from the bottom to the top, and then we just have the number on the bottom. That's the math hack. Okay, cosine is adjacent side, negative 3 over 3 root 5. Okay, what can we reduce here? 3 divided by 3 is 1, right? So this is going to be negative root 5 over 5. Because 3 divided by 3 is negative 1. So we have a negative 1 on top and just root 5 on the bottom. And then tangent is opposite, which is 6 over adjacent negative 3. 6 divided by negative 3 is negative 2. Okay, so we're always trying to reduce our answers as much as we possibly can, because this is how you're going to see it on a standardized or a multiple choice test. Okay, so now our reciprocals. We have 3 root 5, which is the hypotenuse, over 6. Okay, so 3 root 5 over 6. What can we reduce? The 3 and the 6, which becomes a 1 root 5 over 2. Root 5 over 2 is the cosecant fraction. Okay, secant is 3 roots of 5 over negative 3. 3 divided by negative 3 is negative 1. So negative root 5, right? There's no more denominator. Since the denominator is a 1, you don't ever have to write divided by 1. And then cotan is negative 3 divided by 6, which reduces to negative 1/2. So we always want to reduce our ratio as much as mathematically possible. Sometimes it's not mathematically possible and you leave it how it is. Okay? Good job. So if we don't have a unit circle, then we have to make a triangle. Okay, and your coordinate tells you the x side or the adjacent side and the y side, so that you can still write your 6 trig ratios from there after you calculate your hypotenuse. Okay, have a great day. Be good.